So here's a massive question for you. Can artificial intelligence actually solve one of the biggest security challenges in the digital world today? It's a huge deal, and the answer? Well, it could affect a problem that puts billions of dollars on the line every single day. Let's dive in.
And I'm not exaggerating here. We're talking about over $100 billion. That's the amount of value that's routinely being secured by open-source crypto assets, all locked away inside these things called smart contracts. It's basically a digital fortress holding a small country's GDP.
But here's where it gets kind of terrifying. Imagine that $100 billion vault was built with a tiny flaw. A flaw that, once the vault is sealed and running, is permanent. Like you can't fix it, ever. That right there is the fundamental high-stakes challenge we are staring down.
So what's at the core of all this? It's the smart contract. The easiest way to think about it is like a digital vending machine. It's just code that runs itself on a blockchain. Once you launch it, it just goes. It's totally autonomous. And here's the real kicker. It's permanent. Because it's literally written into the blockchain's ledger, you can't just go back and patch it. And this unchangeable, unstoppable code is often controlling just massive pools of money.
So you get this perfect storm, right? You've got massive amounts of value mixed with code that is basically set in stone. And that's created what we can only call a billion-dollar code problem. A single mistake, one tiny little vulnerability, and you could see catastrophic, completely irreversible losses.
So how in the world can we figure out if AI is even ready to help secure all this? Well, that's where EVMbench comes into the picture. It's a brand new testing ground, a benchmark, designed for one specific purpose: to see if AI can handle the pressure of securing these incredibly high-stakes contracts. And this isn't some side project. It was developed by two absolute heavy hitters, OpenAI and Paradigm. And EVMbench's goal is actually pretty simple, but it's also absolutely critical. It's all about creating a standardized way to test how well an AI can actually do the practical, real-world jobs of a top-tier blockchain security auditor.
Now, what's so cool about EVMbench is how focused it is. This isn't about some abstract, theoretical stuff. No, it's about measuring an AI's real performance on real-world vulnerabilities. It zeroes in on three very practical tasks, which we'll get to in just a sec, and the whole thing is repeatable and automated, which means you can't fudge the numbers. The results are the results.
And that brings us to the core of the test itself. I want you to think of it like an AI gauntlet, a series of challenges specifically designed to push these models to their absolute limits and see where they shine. And maybe more importantly, where they completely fall apart.
Okay, so this gauntlet is broken down into three key parts. First, can the AI detect a known flaw just by looking at the code? Second, can it actually patch the flaw? Fix the code without breaking the entire thing. And third, can it put on its hacker hat and actively exploit the vulnerability in a safe, controlled test? And the way they're graded is honestly brilliant because it's all about hard proof. For detection, it's simple. Did you find the known flaws or not? For patching, the scoring is super tough. The fix has to actually work, and you can't break the original contract's functionality. And for exploiting, success is measured by cold, hard evidence on the blockchain itself, like were the funds actually drained? There's no wiggle room.
All right, so the tests were run. The gauntlet was thrown down. What did we actually learn about where AI is at right now? Let's get into the verdict from these first really crucial rounds of testing.
The single biggest takeaway, hands down, was this: AI is not a jack of all trades when it comes to security. Not even close. Its performance was incredibly uneven across those three main tasks. It's absolutely amazing at some things, and, as it turns out, surprisingly bad at others.
And here is just a stunning example of where AI shines. Alpen Yüksel from Paradigm puts it perfectly. He said that a little while ago, the best AI models could only exploit less than 20% of the bugs they were tested on. Today, the latest models are exploiting over 70%. I mean, just think about that. That is a mind-blowing jump in capability in a super short amount of time.
And this chart really just puts that into perspective. I mean, look at that difference. This is not some small, steady improvement. We are talking about a revolutionary leap in the AI's ability to act like an attacker, to find a weakness and actually use it successfully. So if you were going to give AI a report card right now, this is what it would look like. Its strengths? Oh yeah, it's great at finding flaws, and as we just saw, it's a rock star at exploiting them. But its major weakness, the area where AI is really struggling, is actually fixing those flaws.
Right now, it is a much, much better attacker than it is a defender. So why is that? Why is patching so much harder for an AI? Well, a good patch requires so much more than just spotting an error. It demands this deep, almost intuitive understanding of why the code was written the way it was in the first place, so you can fix one thing without accidentally breaking 10 others. And that kind of deep reasoning, that's still a massive hurdle for AI. So what does all this mean for the future? Where are we headed? Let's talk about the pretty big implications here for blockchain security and AI's new and rapidly changing role in it.
So here's the bottom line. AI is getting very good, very fast at the offensive side of security. At the same time, its defensive skills, like patching, are lagging way, way behind. And that's exactly why benchmarks like EVMbench are so vital. They let us track this growing gap. This lopsided progress is creating a whole new dynamic, a sort of new age digital arms race in the security world.
Which leaves us with this one final thought to chew on. AI is quickly learning how to be a master lockpick, able to find and exploit the tiniest little flaw in the most complex systems out there. But based on everything we've just seen, can we really trust it yet to design the lock? That's the billion-dollar question that we're all going to have to answer, and probably pretty soon.